very good evening, dear educators. My name is Mehreen Shamim, and I welcome you all to yet another interesting session on machine learning algorithms, where we'll explore the concepts of supervised learning classification algorithms. So before we start the session, we would like to extend our gratitude to IBM for partnering with us. The grade 11 and 12 AI curriculum has been revised with the support of IBM and facilitated by 1M1B Foundation as IBM's partner. This initiative is part of our ongoing commitment to building and strengthening the AI teacher community in India, and these training sessions are a crucial part of this mission. So today's resource person is Ms. Jyoti PB. She is co-principal in Jyotis Central School, Trivandrum. She is an accomplished educator with over 2 decades of experience in the fields of teaching and technology. Holding a master's degree in computer applications, she has dedicated 15 years to teaching and shaping young minds with her expertise and passion for education. Her professional journey also includes 5 years of valuable experience as a software professional, giving her a unique edge in integrating technology with education. As a CBSE resource person, Jyoti ma'am has been instrumental in training educators, sharing her extensive knowledge and innovative approaches to teaching. She has also been a resource person for more than 20 impactful sessions conducted both online and offline. And additionally, she is a proud member of the AI advisory team, contributing significantly to the design and curation of the grade 11 and 12 AI curriculum, aligning with the evolving educational needs of the digital era. So let's extend a warm welcome to Jyoti ma'am. So Jyoti ma'am, over to you.
Thank you so much, ma'am. I think I'm audible.
Yes, you are audible, ma'am.
Yes. Okay. So is the screen visible?
Yes, it is, ma'am. It is visible.
Yes. Recording in progress. Just 1 minute, ma'am. I just wanted to see the chats also, so I just kept it up.
Yes.
1 minute.
You can enable it and you can keep it on your screen.
Okay, ma'am. So, good evening, dear teachers. I'm really proud to present here for the second time. First, I have taken capstone project. Now, with you for the session classification. And I know you all will support me. So, going directly to the session. So, here today we are going to see 3 topics: supervised learning, classification, and k-nearest neighbor. Okay, supervised learning, I think for many sessions, many teachers have taken a lot of things related to supervised learning. So, dear teachers, what is supervised learning? Can someone tell? Supervised learning?
It's a type of machine learning where the system learns with labeled data set and the target is known to the machine.
Yes, it is so. A type of machine learning, and the main thing is we are teaching the machine with some labels. Okay, so there are 2 main types of supervised learning, and it is classification and regression. So here we are having 2 figures, isn't it? Graph A and graph B. So which is classification here? Teachers? Which is classification and which is regression? It is very easy from the graph itself. Which one is classification? Yes, many are responding in the chat. It is graph A. Okay, so from this graph itself, we will understand what is the difference between regression and classification. Classification really looks into categorical variables. Okay, and here regression is continuous. So last session and the before session all, the teachers took regression very clearly and hope you all know the regression well now. So for this session, we are concentrating on classification. Okay. So basically, I will introduce some pictures here which depicts classification. Okay. So if we are seeing just here, the vegetables and groceries, the whole things are here together. And here we are having the classification model. And after that, it is being classified into two. Okay. Like vegetables and groceries. So there are two types here to be classified. It is vegetables and groceries. And if we are coming to here we are having a group of fruits. Here, apples, strawberries, and some pear-like fruits. So here we are having three classifications. Okay. One group is apple and one is another fruit and one is strawberry. Like three labels are being given here. Here, different, if you are saying this is the same graph which is being given in the study material, here the labels is different. We are having 6 labels. So depending upon the labels, we can classify as many as objects we can through a classification model or through an algorithm. Are you following? Okay, now we will see the little bit more details. Here I'm having different images of cats. Okay, sometimes you may not be feeling like this is a cat, but I'm training my model, classification model or the machine as these are cats and the label is cat. So I am telling my machine or AI machine as this is cat. So each picture which is being given to the machine, I have written cat. Okay. So machine knows lot of images and all these are labeled as cat. Now, after when I tested, I'm giving some similar images. Here it is really like a dog and these two resembles to cat. So what my machine does is, my machine checks all the labels which is being given as here. All the images, it just looks and check whether any picture, any image is similar to the one which is being given to the testing image. If my testing image resembles to the label cat, then we will get the output cat. Okay. Otherwise, it is not going to be a cat and of course it will come under not cat. So this is the basic principle of classification. Classify objects, instance, or even the text or anything to some fixed labels. So this is what we call as classification. Okay. So classification is a fundamental concept in artificial intelligence or machine learning, and it involves categorizing data into predefined classes. Okay. And we have to show, as it is supervised learning, we have to assign the labels. And according to the label, the model will be classifying the images or anything. Whatever we are giving as input, it will be classifying into different categories. So talking about little detail, we are having different type of classification. So binary, multi-class, multi-label, and imbalanced. I hope everybody is very familiar with the word binary, isn't it? So what is that? When we tell about binary, what is the thing which clicks you? What do you think about? What is binary? It is 0 and 1. Yes.
0 and
Or
1.
binary is 2. Or binary is yes or no. Yes. So all the classification criteria is no, whatever it is 0 or 1 is anything. We have 2 labels. Okay. It will be only 2 class label. It can be yes or no, or it can be 0 or 1, or it can be true or false, or pass or fail. Anything, it falls into 2 categories. Just as the examples here, it is given, it is spam or not spam. Or if we are checking the images of some scan reports or anything, it can be tell cancer or not cancer. Okay. Or if we are doing some sentimental analysis project, we can tell this is positive sentiment and this is negative. If we are checking into the student's result, there will be two criteria, either it is pass or it is fail. So this kind of classification comes under binary classification. Okay. Now, we will be telling about the multi-class classification. Okay. There we were having only two categories. Here we will be having more than two categories. So here in this figure, how many categories are there? We are having grapes, we are having banana, apple, and also orange. Okay, so here we are having four categories. That means four classes we are having. So when we have four classes, we tell that it is having more classes or multi-class classification. Okay, so some of the examples of multi-class classifications are plant species. Lot of species are having. So when we take a new species, we should have many classifications. Optical character recognition and face classification, face attendance and all. When we are taking, we are having a class full of students, isn't it? So each student is a class. So it is multi-class classification. So we are having one more thing. We are having multi-label. Okay, more than one label is there for the classification. Here in multi-class, most of the time the teachers get confused with multi-class and multi-label. So that's why I have given a clear distinguish between this thing. So here we are having multi-class, and the next here we are having the multi-label. Okay, so multi-class here, look, we are having sun, moon, and cloud. Only one image per instance. Okay, if it is cloud, we can say it is cloud or not cloud. It is sun or not sun. Only one image. But here, when we come to here in multi-label, in a single image, we are having more than one class. We are having cloud as well as we are having sun. Okay, so for both things, here it is coming to positive. That means inside one image, we are having more than one label. So more label, we make it under multi-label. Okay, we will see one more example for multi-label and class. Here, look, we are having one single image. Okay, actually the machine, when we train, it will be looking like this. Here, dog, it is telling it is 0.7%. Okay, if we are taking into 0 and 1. Cat, it may have some resemblance on 0.1. Like most of the time, the fur and all, it has some similarity, isn't it? So when we take the features, when we think, some features will be similar that of the other animals. So when we have a picture of dog, it might have some features similar to the other animals, but the majority of the features suits to dog. So here it is dog. We are having only one class. It is dog only. We are not having any other images in this picture. So we are making it into multi-class classification. Okay. Here in this image, we are having more than one images. Here we are having dog as well as cat. So when we label this picture as dog and this picture as cat. So two labels in one image, isn't it? So it comes under multi-label classification. Hope now the distinguish between the multi-class and multi-label is okay for you. So can I know now this image now, how many labels are there, or what are the labels in these pictures? Okay, cat, butterfly, flower. Yes. Even some, if you want to know, we can say sun also in between. Small flowers, rose flower. Like that, we can label anything. Inside, even the sky comes under. Yes. So this is multi-label. Okay. So multi-class is entirely different from multi-label. Okay. Now, in some practical aspects, okay, there is a chance of coming like this. If we are taking fraud detection, most of the cases are positive. Okay, fraud is one or two. If we are taking the 100 case of thing, only one or two will be fraud, and all of the 98 things are the correct one. If we are taking a fake news, whatever the news coming, no, 1,000 news are true, while one news comes under fake news. So the majority class is belonging to one group. So there is a slight chance of machine to misunderstand that the majority of the thing is the correct and the minority is not correct. So here it comes majority as well as minority case. Okay, this imbalance classification can be even binary. Here, if you are telling about fraud detection, it comes under sure, it is binary itself, because we are having fraud, not fraud. But the problem is here, we are having two labels, like majority thing is coming under one and minority different. So this type of classification we cannot deal as the other type of binary classifications. Okay, so we have to consider it differently with different algorithms. So we have put this inside imbalance classification. One more example we will see for the imbalance here. Okay, we are having so many birds which migrate from one place to another, and majority of the bird is this rock pigeon. Even though there are some minorities, some different pigeon is there is a chance of thinking the machine as the birds which migrate is rock pigeon. Okay, so this type of classification should be handled very carefully. So these classifications we group under imbalanced classification. Okay, so 4 type of classification, what are there? It is binary classification, multi-class classification, multi-label classification, as well as imbalance classification. Okay. So now, are you okay with all the classifications, different types? So while I was explaining all the classification, I was telling about the classes, I was telling about the labels, isn't it? For classification, labels is a very, very important thing. We should have a label. We should know how we are labeling each thing. Okay. Then we should have the features or attributes. For each thing, on based of attributes only we are classifying. To distinguish between a dog and a cat, we should have some features. So features should be there. Then we have to train it. Okay, hope you will remember this picture. Here, these are the training data, and this is the cat label. Okay, so this is like that. And here, this is the way we are giving the labels. For this is cloud. Okay, so the first 0 belongs to the sun. This is not sun. Second 0 belongs to the moon. This is not moon. And 1 is cloud. So this is cloud. So this is the way we used to label. Practically, when we do programs, we go for the list. When we use Python. So this is how we have to label each sections. Okay, so we should have some training data to build a classification model. After training, we will get a good classification model. So this model, when we get some new data for testing, it will give us the prediction. Okay, so all these things we will see through a program also. So now just I quickly move on to the next portion. It is KNN, one most popular algorithm which we use for classification. Do you have any doubt with this classification basic theory? Shall we move on to the KNN?
No. Yes, ma'am.
Okay, thank you. So K nearest neighbor algorithm. Okay, here from the word itself, we will understand nearest neighbor, who is very near to us, who is staying close to us. Okay, this K is as such which comes in every other algorithm or any mathematical thing. K is a constant and we have to give the value for this K. So some K like 2 nearest neighbor, 3 nearest neighbor, like some whole number values can be given for this. So this K nearest neighbor, it is can be used for both classification as well as regression tasks. It is not an issue. Here we are going to see for the classification tasks. Okay, it is operating based on the principle of proximity. Proximity means distance. Okay, nearest neighbor, I told who is nearest to us in terms of distance. Okay, so it is actually operating based on the principle of distance, and based on the distance, it makes predictions and classifications. Okay, and usually KNN is very useful while the decision boundaries are not clearly defined. Okay, a lot of points are there, a lot of other things. We are taking an animal and an image of animal, and when we look the animal, we feel that it is so close to cat or so close to a little tiger cub or some other animal, just very close. So if you want to identify the image, what is the image, then we can go for KNN. And it also very frequently used in identifying the textual images like handwritten images. Most of them are 2, 5, 4 and all very similar. You also know that our students are writing letters similar to some other letter. Okay, capital F, capital L, everything looks similar. So those kind of images can be identified very clearly using KNN. Okay. So here image classification, sentiment analysis, healthcare diagnostics, spam detection, etc. Here these are practical applications where generally this KNN algorithm is used. And to tell it, KNN is a very easy algorithm which every student can use. Okay, we are having a capstone project, so any classification programs or classification project, we can very easily use this KNN. With very less number of codes, we can use KNN and we can get the predictions very fast. And it is not having any confusions or anything. So first we will see K-nearest algorithm, how the steps, okay? And at the end, we will move on to the Python program for KNN, okay? Is it good going? Shall I move forward?
Yes, ma'am.
Yes, ma'am.
Yes. So here we are having 3 different classes. I've taken 3 different classes. Some points like yellow color, red, and here gray. I have given just simple colors, and I have to predict this point, the new given point, to which class. I don't know the values of this given point, and I want to know which group or which class this comes. So as I have to assign this to a class, this is a classification problem, and I am going to solve this using KNN. Okay, so first what I have to do is, as I have told, we have to calculate the distance. Okay, I have to calculate the distance to each and every point of all the classes. So here I'm having all the point and I have to calculate the distance. So now we have to know how to calculate the distance. There are 2 ways to calculate the distance: Euclidean distance or Manhattan distance. Okay, so this formula, we are having the summation of the distances of all features. Okay, just I will show you one practical example. Here, look, this is the given point and this is a point in a class. Okay, we will be having different features. For example, just as the same to identify a dog or identify a cat, we will be not identifying with a single feature, isn't it? We will be seeing with the face. We should have a lot of different features, isn't it? We have to take the mustache or the skin, the fur, or the color of eyes, then the shape, the size, yes, yeah, everything. All these are features, okay? So when we take this thing, here class, the given point is an animal. You just think like that. The given point is an image of an animal, which we don't know to belong to which class does it belong. And this one yellow color point is an animal which has a lot of features, okay? So to understand the distance between these features, what we will do is, we will take the feature, the first feature. The feature is the mustache. Okay, mustache is the great well-defined feature for a cat. So for the that feature, for the given point, the number is 9, and for a point in a class, we have given 14. Anyway, every feature should be pointed in numerical values. Only then we can do something, isn't it? So these are the features. So different 7 features we have taken, and we have the feature value. So this is Euclidean distance. So we are calculating the distance like this. 9 minus 14 the whole square plus 15 minus 4 the whole square. Likewise, we will minus and square, and we will sum it. Then we will take the root. Okay, so that is this. We will take the x minus y the whole square, and then we will sum it, and finally we take the root. Hope you understood the Euclidean distance, how to take Euclidean distance in the practical concept. This is the way we have to do it. Okay, so Euclidean distance is mainly preferred as Euclidean distance, and in some cases, practical aspect, we can go for Manhattan distance also, because it is taking the absolute value. Okay, so what we are doing is we are taking the distance. Now we have the distance, and now what we have to do is we have to sort it in increasing order, decreasing order, anything. It is better to sort it in increasing order, because we can know who is very close to that point. Okay. Then now what we have to do is we have to select the value of k. Okay. This is the most important thing. If I'm selecting the value of k equal to 7, I'm taking 7 means here the yellow points are 3, then this ash color is 4, and red is 0. So which is having the more color? It is ash. So what is my given point belongs to? My given point belongs to 4. That is ash color, isn't it? So select the value of k. Consider the least distant k neighbor. So 7 is the nearest 7 neighbors. Okay. And we have to count the number of data points in each category, and which has more number we will assign. Okay. Now you tell if what will be the result of taking k equal to 3. I'm going to take k equal to 3. So my given point will belong
Yellow
to
color.
which
Yellow.
one?
Yellow. Three.
Yes, it is yellow, because 2 yellow and 1 ash. So sure, it is 2 yellow. Okay, so what happens is, and if it is k equal to 2, then also it is yellow. So when we go for very small values of k, then it is not, most of the time we won't get the accurate value. So now we will see what happens when it is k equal to 12, when we are taking all the 12 distance. Okay, so now it is yellow 4, ash 5, and red 3. Red also came into role, but it is not most of the values. So k equal to 10 means again we are moving into the ash itself. So smaller value of k will consider the noises, what outliers, everything. And also if we are taking a larger value of k means we have to compute the distance, everything, and the computational cost is going to be very large when the k is very big, isn't it? We have to do the calculation. Calculation increases the computation cost. So it is always best to take the k values in between 3 and 10. Okay. And how to take 3 and 10? You just select the value of k. First you take 4. You just see the prediction value and check whether prediction is right or not. Then go for another k. And thus that way we can optimize the value of k also. Okay. With the no-code platform, it is very easy for changing the value of k and all. So it is easy. And even with Python programs also, I will show you how to change the k. Okay. So now, seeing the advantages, of course, it was very easy to understand. I hope you all understood now what is classification and what is KNN. Okay. Sure, ma'am, it is done. One person have asked me about the website to check KNN algorithm. It is there in our curriculum itself in the study material. Please check in the down. You have the link for KNN algorithm. Okay. Just refer to our study material. Everything for a teacher is being given in the curriculum itself, in the study material itself. So to the end, please check. We have a separate link for KNN. Okay. And for seeing it is no explicit training phase, directly from the training data, it is being learned. And it is very nice that for both classification and regression we can use. And also it is really checking to outliers and also noisy data. Okay. And of course, KNN, if we are going for large K, it is computationally very expensive. And when we have to consider very large data set, of course, K will increase and it is not good. Okay. And sensitivity to the choice of decision metric, because we are really in confusion whether we have to choose Euclidean or Manhattan. So that is also a problem. And also, here one feature scaling is there. KNN cannot handle large values. So we have to scale it and we have to decrease the values to very small numbers, 1, 2, like that. So without feature scaling and pre-processing, KNN is very difficult. That's why that are the limitations. Okay. So high dimensional data and all, it is very difficult. If the features are less, KNN is very good. Okay. So now we will move on to Python program. Okay. Okay, I have already opened Jupyter one workbook for you. Just to decrease the time. Already it is 6:40, I think. So we will check. We will do this with simple libraries like pandas and NumPy and scikit-learn. Okay. So I hope all of you know to install pandas, NumPy, scikit-learn and all. It was already covered in the chapter Python, which was already taken. So we will just quickly move on. Okay. So here, I have already created a CSV file. Okay. So whatever, I will show you the CSV file. Are you able to see the CSV file here? This is the CSV file I have
Yes.
prepared.
Yes.
This is having some user ID, here gender, age, salary, and this is somewhat purchased something. Okay. Purchased, you can say some car, whether these persons have purchased a car or not. So if they have purchased, we have given 1, and not purchased, we have given 0. Okay. So we are predicting based on age and salary. Because here user ID and gender, it is not that much dependent for purchasing. So we have taken age as well as salary is determining the value purchase. So purchase is the label, whether they have purchased or not purchased. So not purchased is 0 and purchased is 1. Okay. Simply, I have written some values and here I am having some 28 entries. Okay. Very small CSV file I have created. Just type the file in an Excel and just save it as CSV. Okay. I have saved here. And what I have done is I have saved in the folder 1M1B like that and have given the full address here. Okay. I have imported NumPy and also I have imported pandas. So both the library I have imported, and using the pandas function read underscore CSV, I have uploaded my CSV file into this program. Okay. So this file, I hope you understood this one. Okay. And just what we can do one thing, which is we will see whether the CSV file is coming. We will use the function head. Okay. Yes. So now this is the thing. Just it is similar to one. This is as it is data frame. The index have come and all other columns is there. If you want to see the first 10 rows, it is symbol. Inside the head, you can give 10. So the first 10 rows will be displayed. So we can know that all the files, all the rows are being coming. So I have imported the library. The first thing we have to do, and I have done, I have uploaded the CSV file. CSV file I have saved in the folder and I have given the full path, full absolute path I have given here. From starting from the C drive, I have given the full path. If you're uploading into the drive or something in the Google Drive or cloud or anything, whatever be that, the full link you can give. So the CSV file will be downloaded. If you are just giving some link from the site, just give the link here also. So it will be included here. Okay. So now the second part, we have to determine the dependent and independent variable. Okay. So what we have to do is, we are doing this thing with age and salary, isn't it? So I have used ilog function. So the second and third index columns, that is, this is the 0, this is 1, and this is 2. Age and salary column I have given for the value X. And for Y, I have assigned the fourth column. And fourth column is the purchase column. Okay. So if we can do one thing, we will just see the print X, and this is the X value. The X value, we will be understanding that age and salary. Okay. And we can like even print Y also and see Y. So for using, I will just comment X. So now we will see what is Y. Okay, so Y is this one. That is the purchase column. Okay. So here we have assigned the values for X and Y here. Okay, now what we have to do is, we have to split the data for training and testing. We have to train as well as we have to test, isn't it? So for training and test, we will be using the function train test split. Okay, train test split is a function which is there in the sklearn library. Okay, in the sklearn library under the submodule model underscore selection, we have a function train test split, and train test split will help us to train the data set into two data set. That is, some data for some values for training and some values for testing. Okay, here we are having X train, X test. Like this means these are the X values for training. Here we are having some values here. No, already here we are having. So these values for X values for training, X values for testing, and Y value for training and Y value for testing. Okay, so this is the thing for the function train underscore split. What is this train underscore split? We are giving the parameters X, Y, and as well as test size. Test underscore size is the parameter which mentions how much data we should give for testing. Here 0.25 means it is 25% of the data. Okay, so I'm having total 28 rows. Okay, from starting from 2 to 29 means it is 28 rows. So what will be the 25% of the 28? Who can say what will be my 25%?
8 records.
8, 28, 14, I think it is 7. Is it? Okay, before saying 7 or 8, we will just check out what is the values which is being given for the testing. We will see what is X underscore test.
7.
Okay, so these are the values. Okay, here I will show you. I will print X also. So this was our X. We were having all 28 records here. And from this record, we have taken 7 records randomly. Okay. So this random state equal to 0 means that whenever we use this equation or with this statement to produce this training and testing values, same values will be given. If random state 0 means same value, same test train values will be given each time when we run the program. Okay, so these 4 things should be given under train test split function. X value, Y value, and we have to mention test size. Here I have given 25%. Test size should always be given 0 to 1. Okay, 0 to 1 means here 0.25 is 25%. If I am giving 0.2 means it is 20%. Okay, random state 1, 2, 3 like this. Different values are there for random state. 0 means always one value, and 1 is the random state is using the random function, and accordingly the random will be mixed, and the values regenerated will be sorted, and every time when we are doing, we will be getting different values. Different test values will be there. Okay. Random state equal to 0 means every time I am running this program today, I will be running the program next day. Every day when I am running, the same kind of test values will be given. These are my test values. Okay. So if the random state we are giving different values means the values will be different. Function random state has very low importance, so no need of worrying about it. You just take the important portion, test size is equal to 0.25, because this is the thing which determines how many values should come for test and how many values should come for train. So this is the most important thing. We have to give X input value, Y input value, and as well as we have to give the test size equal to 0.25. Okay. Now we have splitted the value for the training and testing. And now it is the time for doing the KNN. We have to do the classification using the K-neighbors. Okay. So for that, we have the function K-neighbors classifier. Okay. This function is coming under the library sklearn again. And we are having the submodule neighbors. Okay. From the submodule sklearn, we are taking the function K-neighbors classifier. Okay. So this classifier is a variable, and I'm using this K-neighbors classifier as the function, and n_neighbors equal to 5 is the value of K. I'm here taking K as 5. Okay. Matrix equal to Minkowski means this is a general default thing as giving. This value means that the distance can be Euclidean distance or Manhattan distance. Both the value can be there. So we are giving metric equal to Minkowski. Okay. And P equal to mean 2 means we are taking Euclidean. I told if we are using metric equal to Minkowski, 2 things, either Euclidean or Manhattan. If I am using P equal to 1, then it will be Manhattan. If I am using P equal to 2, then it is Euclidean. So here I am using Euclidean. So I have written P equal to 2. Okay. So my KNN thing is ready. Now I have to train it. So this is the sklearn function fit. And here I am training using X train values, and as well as I am giving Y train values. Okay. So see, let us see. So while I run, now the K-neighbor classifier is being created. Okay. Now what we have to do is, we have done the classification, isn't it? Now we will have to predict. We have trained the thing. Now we have to see what will be the prediction value. So to understand the prediction value, we have a function called predict. This is under what? The sklearn itself. And we are having this function, and we are using here, we are having this predict function, and we are going to predict. Okay. So we will see what is the predicted value. Here it is this. For the 2 values, for the 2 test values, already we are having the test value, isn't it? So for the first test value, that is 26, age and 43,000, they will be buying the car. And for the next 2%, they won't buy. And the next person will buy the car. So this is the predicted value for each test. Okay. And it is also, if you want to have confusion matrix, there is also code. We can see the confusion matrix. Okay. So let us check for the confusion matrix also. I hope you remember the confusion matrix and all. True, positive, true, negative, everything, isn't it? So now I am not showing as the table way. This is the simplest way of showing the Python output. Here it is 5, 1 and 0, 1. So can anyone say what is 5? 5 means what is the first block?
True positive.
Positive.
Yes, it is true
It is
positive.
true
Then
positive.
one
Yes.
is, it is false positive. Then
False
here
positive.
false negative and true
0
negative.
is false
So we
negative,
are
1 is
having total. Yes, ma'am.
no,
We
nothing,
are having
nothing.
With the
6
confusion
cases.
matrix, no,
Yeah.
prediction is seen on the top and reality is seen on the left. It's not like how we
Yes.
have it in grade 10 textbook. So here true positive is 5, false positive is 0, false negative is 1, and true negative is 1.
Yes. So that here 5 and 1, this one will be the thing which we get. Now, from this code, what we have to understand is we have to test what will be the prediction for the new values. Okay. So here we have taking new values. So test value we will take. So the thing which we have to give is the age and salary, isn't it? So for the test variable, I'm giving 43 as the age and 35,000 as thing. And for the same classifier, I am using for the predict. And when I am running this, I'm getting 1. That means this value will buy the car. Okay. Let us see some other value where I will change the age to 20. Then I will check whether this person is going to buy. Yes, this person is also going to buy the car. Now, small change for the salary. I will check 20-aged boy or girl with 15,000 salary. Will they buy? No, he is not going to buy. So this is the result. So we have taken a file, CSV file. We have trained using KNN, and then we have come to the result. Okay. The time is around 6:56. So this is how we can do a simple project. We can ask our students to go for the classification, everything, and we can do this. Okay. And ma'am, most of the person have taken why not FP equal to 1 and all. Here, the portion what I have left is I have not done feature scaling. Okay. I have told for KNN to get the correct best result, we have to do the feature scaling also. Okay. So the feature scaling portion I just omitted because the output we will be getting in terms. When we give the test value, we can give this directly the value we can give. But if we are doing the feature scaling, after the scaling values, what is coming, that is the thing we have to give input. So for a better understanding, I did not use feature scaling. Okay. So for a best result, for getting the confusion matrix correct, we have to go for feature scaling also. Any other questions? Erin ma'am, I think I'm on time. I did not exceed your timings.
Yes, ma'am, you are just on time. And don't worry. I mean, I think teachers, if they have some doubts, they can always put them to you and you can solve them. So teachers, if you have any doubts, you can put it to ma'am and ma'am will be happy to clear your doubts.
First question, I will ask whether you understood.
It was an excellent session, ma'am. And I'm sure teachers have benefited sitting in this session. Yes, we will be sharing the recorded video soon, ma'am. Any queries you
The
have?
CSV file, no, these CSV files, I just took some examples. You can make any CSV file you like. That's why I just took some 28 rows. Even you can take your students' details. You can add as PT mark, CT mark and all, and you can just predict how much, whether they will get what above 80 or not 80. Like that all you can create. You can ask your students to prepare the Excel sheet. So these CSV files, we doesn't want to download from any site and all. Just prepare your own real life examples and all, and you can start doing it. So it is very simple to do the classification problems. Program part, for any classification, no, at least one algorithm they should be knowing very well. If we are telling that, is it necessary? You have seen how many lines of the program is there. So we have to introduce some programming concept to the students. Only then they will be having an idea for doing the capstone projects. So it is always better we are giving some exposure to some kind of Python programming. So KNN, very less number of codes, and also the importing part, the CSV file uploading part, everything they know already. So only 4-5 lines, no? That is very easy for them to understand. And even they can prepare any CSV file and they can do it by their own. So when they get the result, they will feel happy and they will really enjoy studying AI. Otherwise, simply going on with the theory portion, they will feel very bored. So it's better you just give the code to them, and also you can give us a homework for feature scaling, because feature scaling portion is already there in the study material. You can ask them to include it and do the program. So they will do it. So you can give an assignment or like that. So as teachers, we should open a wide area to them for every level of student. For very weak student, we can give the program, and for other brilliant student, just let them explore. Let them come with many more functions and all. Let them study KNN. Okay.
Informative session. And frankly speaking, I've been teaching class 10 for a very long time. But today is the first time that I've understood how that code actually works, because I always used to think that how will I actually, make them do the project. I teach IP also 11, 12 for a very long time. So I've been doing Pandas projects with them. So once we go for the IP ones. So that is what we've been doing. But this has really given me an insight as to how exactly they can implement the concept which they learn in classification. Thank you so much. And unfortunately, I could not attend the other Teach AI series. But now I'm like going to hunt all the YouTube channel links which ma'am said is there. And I would definitely see the other sessions also. This was excellent, ma'am. Thank you so much.
Thank you, ma'am. Thank you.
Thank you so much.